We are starting Learning Target 18, which is point slope form. This is also what I call the asylum equation. So if we take a look at the form, we've got y equals m times the quantity x minus x1 plus y1, where m equals our slope and x1, y1 is a point. So when you look at the equation, the y and the x are variables. The rest of them will be numbers. So this is the asylum equation because inside the parentheses is the asylum. So everything in the parentheses doesn't act normal. So notice how this looks like a negative, but over here in the ordered pair, it's positive. So it's the opposite of what you think. And then we have this y1 outside the equation or outside the asylum, and it's positive, and in the ordered pair it's positive. So when it's outside the asylum, it's normal. When it's inside the asylum, it's not normal. So keep that in mind as we're using this. All right, the first thing we're going to do with our point slope form is learn how to write an equation. Step 1, substitute the values you're given into the asylum equation. We're given the slope and the point. So it is helpful if you write down the equation first. This is helpful for two reasons. One, if you write it down every time, you'll get it memorized, which you need to have it memorized. And then two, it makes it really easy to just directly substitute right into the equation with the values that we have. All right, so our first value is the slope, so we substitute that for m. And then the -1 is the x1 or the x coordinate, and 8 is the y1 or the y coordinate. So when we put that -1 into the asylum, it does not act normal. Normally it's a -1. Inside the asylum, it's a +1. And then our 8 is outside the asylum, so it is normal. It's a +8, so it's a +8 outside the asylum. If you think of it that way, you get your equation in simplest form in one step instead of in two. You could replace your x1 with a -1, but then you'd have to remember your subtracting rule and add the opposite and simplify it to a +1 anyway. So the asylum analogy is helpful for that. Now, we also want our equation in final form solved for y in slope-intercept form. The reason for that is that when an equation is in slope-intercept form, it is a unique equation for that line. It's got the same y-intercept and the same slope for the entire line. Whereas when you use point-slope form, there are literally millions of different points on the line that you could use. So each line can have millions of different point-slope forms of the equation. So it's hard to tell if two point-slope equations are the same line or different lines. So when we solve for y, we get a unique equation and we know we're talking about the same line. So in order to get it in slope-intercept form, we're going to start by distributing our slope. So we get 2x plus 2. We do not distribute the slope outside the asylum because it's being added, not multiplied. And then combine our like terms to get our equation in simplest form. We've got 2 plus 8, which gives us 10. Let's take a look at one more. Of course, we've got to see one with a fraction slope. So we're going to write down our point slope or our asylum equation. Again, two reasons: get it memorized and easy to directly substitute into. So we're going to replace our m with our slope. Replace our x1 with the 9 and its opposite, or it's not normal. Normally it's a +9. Inside the asylum it's a -9. Outside the asylum we've got our 4, which is normal, so it's a +4. Distributing our slope to get this solved for y. We've got 2/3 x, and I'm going to show my work here. Most of you like rewriting that 9 as a 9/1, makes it a little bit easier when you've got to multiply by a fraction. So remember, when you do multiply by fractions, what I'm going to do here is this bar means divide. So I'm going to divide my 9 by 3 to simplify before I multiply. 2 times 3 gives me a 6, and then -6 plus 4 is -2.